Now we're going to move on to our last objective, which is to apply the slope-intercept form of a line. We've already seen the standard form of a line, the ax plus by is equal to c, and we've seen that that's a very easy form to use in order to find the intercepts. But the slope-intercept form of a line is y is equal to mx plus b. M is the slope of the line. We just talked about the slope formula. And B is the y-intercept of the line. In fact, remember that we already know, generally speaking, not just for lines, for any equation, to find the y-intercept, you set x equal to 0. Well, if I were to set x equal to 0, that whole term would go away. And I would just have that y is equal to b. So that is why b is our y-intercept. So to put a line in slope-intercept form, what's important is that the equation must be solved for y. So if you have an equation, for instance, if I were to go back to the first example here, this is not in slope-intercept form because it's not solved for y. But if I were to take this equation and get y by itself and solve for y, then I would be in slope-intercept form. And we're going to see some of the benefits of slope-intercept form right here now. Okay, so write the equation in slope-intercept form, use the slope and the y-intercept to graph the line. So first things first, if we want to write the equation in slope-intercept form, this part alone right here means solve for y. Don't plug things in, just solve for y. Okay, so let's solve for y. I'm going to start off by adding 2x to both sides of this equation. Let me just rewrite the equation. So we start off with 3y minus 2x is equal to negative 6. I'm going to add 2x to both sides of the equation. So I have 3y is equal to, and just to keep it like the mx plus b term, you see how the x term comes first? I'm going to write the 2x term first. Okay, and then I'll add the minus 6 off at the end. We still do not have y by itself yet, so we need to divide both sides by 3. I would encourage you to, instead doing it like this, where you just put two big divisions by 3. When you divide by 3 on the right side of the equation, instead divide each term by 3, okay? Like that. So this is canceled. We have now solved for y. I have y is equal to 2 over 3x, right? I don't have to put the x in the fraction. I can just stick the x right next to the fraction. Those are the exact same thing. And then 6 over 3 is 2. So now I can see that m is equal to 2 over 3, and that b is equal to negative 2. I'm looking at this form here. Y is equal to mx plus b. B being equal to negative 2 does tell me that my y-intercept is the point, because intercepts are points, not just numbers, even though your homework says they're numbers. I don't like that, but I didn't build it. The y-intercept is the point 0, negative 2. Generally speaking, your y-intercept will be the point 0. My head's in the way. The point 0b. Okay. So now that we have the line in slope-intercept form, I just want to make sure that's clear. This is slope-intercept form, because that is the equation once we have solved for y. Now let's graph it. So we already know one point on the line. We know the point 0, negative 2, because I know the y-intercept is 0, negative 2. So I'm going to go ahead and plot that point. I'm going to go ahead and plot that point there. There's our y-intercept. And now I'm going to get some more points on the line. The slope is 2 over 3, and it is a positive 2 over 3. The slope is positive. So how we can apply that to get another point on the line, you can think of the slope, which is 2 over 3, as rise over run, change in y over change in x. The rise is 2. So I'm going to go up 2, 1, 2, and the run is 3. So I'm going to go over 1, 2, 3. And that puts me at this point right here. Now I have 2 points on that line. I can connect those 2 points and draw the line. I want to show you one other way you could have done that, just so we can kind of wrap our heads around slopes and things. The slope is a positive 2/3. Keep in mind, I could have written that as this as well. A negative 2 over a negative 3. The negative 2, we're still going to start at the same point we started at, right? The negative 2 would tell us to go down 2, because that's now negative, to go down 2 from this point. And the negative 3 would tell us to go left 3, to run to the left. So I'm now going to run 1, 2, 3 to the left and get this point on the line. Well, all 3 of those points are points on the line. So now I'm just going to connect this. And that's what that line looks like. You do not necessarily need more than 1 point when you're graphing a line. You really only need 2 points and then you can just connect them. I just wanted to show you how it works when something's negative, right? So just like we do with points, positive is up or right, negative is down or left. Let's look at another example. Example 9, we want to first put this line into slope-intercept form. So I'm going to start off by solving for y. We have the equation x is equal to negative 2y plus 4. I am going to subtract 4 from both sides of this equation. So I now have x minus 4 is equal to negative 2y. If you're like me, once we start doing something a certain way, I don't really like to switch it up. So I'm just going to switch the sides of this equation because we're typically used to seeing y on the left side of the equation. So I'm just going to switch sides and write this as negative 2y is equal to x minus 4. There's lots of ways you could have done that. You could have just moved the 2y to begin with and then moved the x. It doesn't really matter to me. We still do not quite have y solved by itself yet, so we need to go through and divide everything in this equation by negative 2. So I'm going to divide by negative 2, divide by negative 2, and divide by negative 2. And I did that, so now I have y by itself. So we'll fill out the right side, but we know once we have y by itself that we then have slope-intercept form of the line. Because all you have to do to get slope-intercept form is solve for y. So I have a negative x over 2. I'm just going to write that as a negative 1/2 x. Hope everyone agrees that's the same thing. It doesn't matter with fractions if you put the negative in the top or if you put the negative in the bottom, as long as it's there. Please do be careful, though, with that second term because you have a negative 4 and a negative 2. So those two negatives will come together to give us a positive 2. So we can see that m, the slope of this line, is equal to negative 1/2. And b is equal to 2. So I know the y-intercept of this line is the point 0, 2. So I'm going to go ahead and plot the y-intercept at the point 0, 2. And now let's use the slope to get another point on the line. M is equal to negative 1/2. Slope is rise over run. If you think of the negative as being in the top with the 1, that's a negative 1 for the rise, so we really need to go down 1 to get another point. So I would go down 1. The run is a positive 2, so then I would go right 2 to get this point on the line. And then you can connect those 2 points and have the line. You could have also thought of it as the slope being a positive 1 over a negative 2. Then the rise would have been a positive 1. Which would have told you to go up 1. The run would have been a negative 2, which would have told you to go left 2 to end up at this point. And I hope you're seeing how, hey, yeah, all those points are still on the exact same line. It looks kind of sketchy. Let me erase all these arrows in here because hopefully y'all got what y'all needed from that. Hopefully it gave what it needed to give. That's what this line looks like. And you can see that this is a line with negative slope, right? We talked about earlier how lines with negative slope trend in that direction, lines with positive slope trend in this direction, and we can see that that's still matching up with what we're seeing down here, positive slope and a negative slope. Let's look at example 10. Write the equation of a line in slope-intercept form that passes through the point negative 2, 3 and has a slope of 5. So we want the line in slope-intercept form. That means that our answer needs to be y is equal to mx plus b. And we need to find m and b. Well, we already have m. They told us the slope is 5. So I know that m is equal to 5. So I'm going to go ahead and plug that in. So I know that y is equal to 5x plus b. But we need to find b, right? We need b. So to find b, what we're going to do is we are going to plug in the point that they already gave us. They told us that the line goes through the point negative 2, 3. That means that x is negative 2 and y is 3. So we should be able to plug those in and solve for b. So I'm going to be plugging in a positive 3 for y. So I have 3 equals, I already know the slope is 5. I'll leave that there. For x, I'm going to be plugging in the x value of negative 2. And now we can solve for b. So we have 3 equals negative 10 plus b. I'm going to add 10 to both sides of this equation so I can see that 13 is equal to b. So now that we know m, which was given to us in the problem, is 5, and we also just used the point that they gave us, the point that I circled in purple, we used that point to figure out what b is. So now I know that the line in slope intercept form is y is equal to 5x plus 13. And now let's graph it. And in all reality, we could have graphed this line. I should have put some graph paper on here. We could have graphed this line from the start. I know that the line goes through the point negative 2, 3. This is going to be a rough sketch. So I'm just going to go left 2, up 3. I'll say this is the point negative 2, 3. And I also know that the slope is 5, which is 5 over 1. And I can think of that as my rise over my run. So I could go up 5 and over 1 to get another point that's on this line. I don't like the way this is looking. I'm just going to adjust this to make sure everything fits on here. So I moved my x-axis down because I need to go up 5. So here's my point again, negative 2, 3. Rise over run, if I go up 5 and over 1, going up 5 will put me up at 8. And then going over 1 will put me over at negative 1. So the point negative 1, 8 is on that line. So there is what that point looks like. And now I'm just going to connect those points. So I connect these points. I'm going to extend this off forever. I'm going to make my y-axis just a little bit longer because I want to stress, try to keep this line straight. I want to stress that we found that b, I know my line is crooked, but y'all get the point. We found that b is equal to 13, which does tell us that the y-intercept of this line is 0, 13. Hopefully you see that if you were to apply rise over run one more time to this point, you would go up 5 to 13 and over 1 to 0 to see that we do go through the point 0, 13. So good, that all checks out. Let's look at graph the end. I'll fix that on the note sheet. Graph the line. Example 11, find the equation of a line that goes through those 2 points. First, let's just graph that line, okay? First, let's just graph it. 18, negative 8, negative 12, negative 4. Okay. X, Y. Let's say that this is the point 18, negative 8 right here. So I just went right 18 down negative 8. And then let's say that this is the point negative 12, negative 4 right there. Left 12, down 4. I'm now going to connect these 2 points and put arrows on my ends and extend so I can see that I have the line graphed already. So a couple things we can tell from just looking at the graph of that line. We're writing the equation in slope-intercept form, so we need to find m. We need m, and we also need b. I know that m is negative, right? Because I can look at the line and see that the slope of that line is negative. And I also know that b should be negative because I can see right here that the y-intercept of that line is negative, right? That line is hitting the y-axis under the x-axis. So let's get started and find m. Any thoughts on how we can find m? We can use the slope formula that we just did. We have 2 points that are on the line. Whenever you have 2 points, you can just plug those 2 points into slope formula to find the line. I'll call the first point x1, y1, and the second point x2, y2. I'm going to go ahead and start plugging in to the formula y2 minus y1 over x2 minus x1. Y2 is -4, y1 is a -8. Be careful with your signs there. I did subtract a -8, so I will eventually turn that into a plus sign. In the denominator, x2 is -12, x1 is 18, so I'm just subtracting an 18. So in the numerator, we have -4 plus 8, and in the denominator, -12 minus 18 is -30. And this is 4. So this is simplifying that fraction, a -2 over 15. 15 goes into both 4 and 2 goes into both 4 and 30. So I know what m is. So at this point, I know that the equation of the line would look like y is equal to -2 over 15x plus b. But we still don't have b. And now we can find b by taking either one of these 2 points. You can take that point, or you can take that point. It doesn't matter because both those points are on the line, and plug in for x and y. I'm going to choose to use, let's just use the second point. I'm going to plug in x is equal to -12 and y is equal to -4. So y is -4, -2 over 15, x is -12, plus b. And now let's get this solved for b so we know the equation of our line. So I have -4 is equal to, multiply straight across the top. Well, actually, let's simplify this a bit first because 12 and 15 have things in common. 3 goes into both of them. 3 goes into 12 4 times. 3 goes into 15 5 times. Now I'll multiply straight across the top and across the bottom. So I had to come back and edit this video because I finished the problem and made a mistake. Be careful with your signs here. Don't be like me, be better than me. There's still 2 negatives here. Okay, so multiply straight across the top and straight across the bottom. We will get something positive. We will get a positive 2 times 4, which is 8, over 5 times 1, which is 5. Now we can continue to solve for b. I'm going to subtract 8 over 5 from both sides of the equation. So I have -4 minus 8 over 5 is equal to b. I'm going to rewrite the -4 as a -20 over 5 because I need to have a common denominator in order to combine those fractions. And now I can combine them to get that b is equal to a -28 over 5, which is correct. So now that we know b, we already knew m. We found m earlier using the slope formula of -2 over 15. Now we have b, so we can combine those together to fill out our slope-intercept form to say that the equation of this line is y is equal to a -2 over 15x minus 28 over 5.